Hi, my name is Ain Siddiqui and I will be presenting my doubly and circularly singly linked list. And so let's get started. So this is my diagram for doubly linked list. So as you can see, this has a head and these are called nodes. All three of these are nodes. They are like a set of data that these are like sets of data that are saved, and these have a different pointers, which are called the previous and the next. And these are the differences between a singly linked list and a doubly linked list, because a singly linked list only has one pointer. And so that is a good thing about this right here, that it has two pointers instead of one. And that is pretty much that is the main difference between a singly linked list and a doubly linked list. And so let's discuss some of the other things like null. So to identify the end of uh, the list, we need to identify the last pointer as null, because we need to identify when it's gonna end, and the head is when it's gonna start. So let's go and let's see the first example. So how do you do insertion in doubly linked list? So let's say this is the first thing that we want to do the insertion in. So we want to insert this node into this node right here. So what we need to do is, first we need to update the next pointer so that we could link that with this one right here. So in order to do that, we will use this temp next is equal to head. And after that, what we need to do is update to this node right here, which is the previous node, which is linked with the head node. And so we're going to be using head prev, previous being prev, is equal to temp. That way it will be updated and it will be linked to this. Then after that, we would use head is equal to temp in order to go on to this step, which will give us the resultant node. And so here you can see that this has been added as we explained. Now moving on to the advantages of a doubly linked list are, like, for example, each node has pointers pointing to the previous and next node. The doubly linked list can be traversed easily in forward as well as backward direction. And so yeah, that is the main difference in between a singly and doubly linked list. And you can also quickly add new nodes just by changing the pointers. The deletion process is also very easy in W-linked list. That is also another advantage. Some of the uses of W-linked lists are like navigation systems, where you go front and back navigation, which is required, and it is used by browsers to implement backward and forward navigation to visit websites. That is back and forward button. So these back and forward button, if we were to click on these, I'm sure you have used these before. So this is a very good example of using these back and forth buttons. When you would click this, it would take us back into the previous memory, and if we were to click this, it would take us to the next memory. So uh, the example that I showed before, it is being stored here. So this is a set of data, and this web page is actually a set of data as well. So we would be able to go to the next and the previous, which would be saved, right? So moving on to the disadvantages of this is that since there are two pointers that are being used, we know that there would be more energy, more space that is going to be required. Therefore, it's going to be wasting more. And so it would be needing more additional memory space. And all the operations like addition, deletion require that both previous and the next pointers are manipulated, therefore imposing operational overhead. And so after that, we will move on to the circular singly linked list. So this one is very similar to the singly linked list, but in this one, what the difference is that the last node, it will be pointing to the head node, as you can see here. So some of the uses of this would be like maybe in a game where you want to loop the game, maybe where the character may die and they would want to respawn, and that would be a good example for what this might be. And yeah, other than that, we can move on to how do you do insertion in a circularly singly linked list. So if we look at this, what we want to do is this is our initial node, and this is our tail, which is leading back to our node. What we want to do is we want to add this. So the first thing that we want to do is you want to update this. In order to do that, we will do new p is next is equal to tail next. That way that will get updated. And then after that, what we need to do is do tail next is equal to new p. That way these two nodes will be connected together because both of them, the next pointer and the previous pointer would be updated. Therefore, it would get linked, and the head node as well. And so, after that, what we need to do is see what the advantages of a circular linked list is. So, the advantages of a circular linked list is that there are no requirements for a null assignment in the code. The circular list never points to a null pointer unless fully deallocated. It could also be useful in situations like in a game where a character would restart back to where they started from. It could be useful in applications to repeatedly go around the list. And moving on from that would be the disadvantages are like singly linked lists are complex as compared to a singly linked list. Reverse of circular linked list is a complex as compared to singly linked list or doubly linked list. Yeah, that is correct. So if not handled carefully, then the code may go in an infinite loop. That is definitely possible and harder to find the end of the list and loop control. So it could be harder to find the end of the list as well. Yeah. So after this, we can move on to the next question that we have. Yeah. So now what I need you guys to do is how would you add a node at the end of the doubly and circularly singly linked list? And so this is a question that you may want to answer and think about according to the steps that I have shown you here. Maybe look over it and see if you can do that. Thank you for listening. I hope you understood what I explained. Thank you.